Hello everyone, welcome to the Mathematics of my channel. In this video, we are going to solve another interesting integral. Integral from 0 to infinity, 1 plus x over 1 plus x to the pi. Well, how to begin? Okay, to solve this integral, first I'm going to define an integral. So I'm going to take this integral from 0 to infinity x to the b minus 1 over 1 plus x to the a dx. Okay, now let us solve this integral. So to solve this integral, first I'm going to rearrange the denominator like integral from 0 to infinity. In the numerator we have x to the b minus 1 over here 1 plus now x to the a. I'm going to a little bit rearrange for your understanding. So here x to the b raised to the a over b, then we know this b and this b get cancelled. Again we have x to the a, so no problem. Okay, here dx. Then to evaluate this integral, I'm going to take a substitution. So let's take u is equal to x to the b, then differentiate. So we have du is equal to b times x to the b minus 1 dx. Okay, let's plug into our integral. Now we know limit also 0 to infinity. Then in the numerator we have x to the b minus 1 dx. So x to the b minus 1 dx is equal to 1 over b times du. 1 over b we can write outside of the integral sign, and here du over 1 plus here x to the b we know u, so u raised to the a over b. Okay, now to evaluate this integral, again we can take a substitution. So I'm going to take here u to the a over b. So let's take u to the a over b is equal to tan square of theta. Okay, then we can isolate u. U is equal to tan raised to the we know 2 times b over a of theta. Okay, then let's differentiate. So we have here du is equal to now 2b over a tan raised to the 2b over a minus 1 of theta. Then according to chain rule, derivative of tan of theta we know secant square of theta d theta. Okay, let us plug in. So we have now here 1 over b, then here du, and we know limits also lower limit also 0, but upper limit we know when u approaches to infinity, tan of theta, so we know theta approaches to pi over 2. So limit integral from 0 to pi over 2, then du we have here du 2b over a we know constant, so 2b over a outside of the integral sign, and then we have tan raised to the 2b over a minus 1 of theta secant square of theta d theta over here 1 plus u to the a over b we know here tan square of theta, and we know 1 plus tan square of theta is equal to secant square of theta, so the secant square of theta get cancelled. Well, now we have this b also get cancelled, so 2 over a integral from 0 to pi over 2. Now here tan, so we can represent tan by using sine and cosine. So we have sine raised to the 2b over a minus 1 of theta sine over cosine. So cosine raised to the 1 minus 2b over a of theta d theta. Okay, now we know this one very nice format because we know about beta function. Beta of mn is equal to 2 times integral from 0 to 5 over 2 sine raised to the 2m minus 1 of x cosine raised to the 2n minus 1 of x dx. So we can use beta function for this integral. So we have here 2 over a. Now this integral, so 1/2 times beta function. So beta of, now m, we know here m, here b over a. So b over a, comma, now n. We know 2n minus 1 is equal to this part. So if we isolate, then we have 1 minus b over a. Now beta function. So we know we can represent beta function by using gamma function. Beta of mn is equal to gamma of m, gamma of n over gamma of m plus n. So we can write here 2 get cancelled, 1 over a, here gamma of b over a times gamma of 1 minus b over a over gamma of this one plus this one. We know b over a get cancelled, so gamma of 1 we know 1. Okay, now again nice relation. So we know Euler's reflection formula, gamma of x, gamma of 1 minus x is equal to pi over sine of pi x. So this one we can write 1 over a times pi over sine of pi x. Okay, now we solve this integral, we define this integral. So this is the integral from 0 to infinity x to the b minus 1 over 1 plus x to the a dx is equal to 1 over a pi over sine of oh sorry, here 5x. So here instead of x we have b over a, so pi b over a. So here pi b over a. Okay, then we have to solve our integral, this one. So integral from 0 to infinity, 1 plus x over 1 plus x raised to the pi dx. Okay, now we can write this integral like integral from 0 to infinity 1 over 1 plus x to the pi, so dx over 1 plus x to the pi plus integral from 0 to infinity, now x over 1 plus x to the pi dx. Well, now comparing with this integral, we know this one. Here in the numerator we have this one, in the numerator we have 1, so b should be 1. So we know b is equal 1, and here a is equal pi, because here pi. Then for this integral we have b is equal to definitely 2 and a is equal to pi. So we have this is the answer. So 1 over a, 1 over pi over sine of pi b over a. So we know pi b is equal 1 and a is equal pi. plus here again 1 over pi times pi over sine of 2 pi over pi. Okay, now this pi get cancelled, so sine of 1 over sine of 1 we know, cosecant of 1 plus here cosecant of 2. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.